This is the second day of plate tectonics for 9th grade, and today we are going to be going over plate boundaries. So this is your belt ringer for today. I want you guys to label this deconstructed model of Earth, and each of the layers represents a layer in Earth. So just take a couple minutes to pause this video and label the model with the terms that are on the right. The answers to these bell ringers, see how many of these you get right. Starting from left to right, top left to right, is continental crust. It is shown by the land masses on Earth. It is the topmost layer of Earth. And below that is the oceanic crust. It is what makes up the oceans on Earth. It is shown by the blue on the little sphere. And then both the continental and the oceanic crust make up the collective term crust, which is the next term on the bell ringer. The layer labeled on the top of the model, the green layer, that also points to the top layer of Earth, is the lithosphere. The lithosphere includes both the crust and the brittle upper mantle. The red layer on the model is the asthenosphere. This layer is about 80 kilometers to 700 kilometers below the surface. The lower boundary of the asthenosphere is not well defined though, and it is hotter and more liquid than the lithosphere. The brown layer, or like the brick-ish colored layer, is the mantle. The mantle is 2,900 kilometers thick. The next layer is the outer core, and it spans from 2,900 kilometers to 5,150 kilometers beneath the surface. Little quiz question. The composition of this layer is what? Give you guys a couple seconds to think about it. The composition of this layer is iron and nickel. And what are these two elements in this layer responsible for on Earth? What process? The outer layer of the core is responsible for the magnetic field on Earth, so north and south. The center layer is the inner core, which is solid because of the shear pressure present here. I also wanted to go over a little bit more review from yesterday because these definitions will be really important for the rest of the unit. Pause this video and think of these definitions again or discuss with a neighbor. The definitions to these 4 review vocab words. Pangaea is the supercontinent that included all the land mass on Earth. Pangaea was formed around 280 million years ago and began to break up around 200 million years ago. The theory of plate tectonics, it was proposed by a man named Alfred Wegener in 1950, and the theory states that Earth's lithosphere comprises the smaller plates that move over the semi-liquid asthenosphere. Continental plates is one of 2 types of plates found on Earth, and it is composed of a lightweight mineral called like feldspar and quartz. And this type of plate can be as thick as 100 kilometers thick. Oceanic plates are the second of 2 types of plates present on Earth. These are composed of more dense and therefore heavier basalts. And these plates only get as thick as 5 kilometers. It is important to note and remember the composition and thickness and weight of the continental and oceanic plates, because that will be important today and it will be important for the rest of the semester, the rest of the unit. So maybe look over that again and then we'll move on. So why did Pangaea split apart? That's what we are going over today, or some of the processes and boundary types that are responsible for that. This is the several processes within its mantle that causes the plates to move, and this slowly breaking apart Pangaea as shown in this little animation. So we are going to focus on the external processes and boundary types that are shown by this animation. Look at India, which is this little continent here, or this little plate here. It starts at the bottom and then it moves slowly up. Notice its movement in relation to the other continents. Is there anything that you notice? You guys can pause this video. I'll give you a couple seconds to look at it and see if you notice anything. Animation from the last slide over to this slide, and if you notice, India is a good example of all three plate boundary types. You can see that the landmass that we would call India, which is this right here, it's traveling north on the map, becomes disconnected from the rest of Pangaea around 120 million years ago. It starts heading up the map and scrapes past a little landmass that we would later call Madagascar, which is this right here. And then it continues north and it smashes into the largest landmass, this right here, that we would later call Asia and Russia and all this. Pause this video and see if you can define these vocab words based on the context and what you see in the movement of India. First vocab word, convergent. Con is a Latin prefix meaning together or with. So convergent means plate boundaries moving together. Diverge means to move in different directions or deviate. So a divergent plate boundary is an area where two lithospheric plates move towards or away from each other, pardon me. And trans is a Latin prefix meaning across. So a transform plate is a boundary where Earth's crusts slide past each other. A little bit about what each of these vocab words mean. Let's go over a little bit more detail about each. So continental plate boundaries, there are three types of continental plate boundaries: continental, continental, oceanic, and oceanic. The names are pretty self-explanatory. So continental is when two continental plates collide. And you can see from this little picture here, the arrows are pointing towards each other, and one continental crust is going underneath the other at an angle. And then the continental crust that is going underneath the first plate here is pushing up the crust and causing a mountain range to be, it's like crumpling that plate up and causing a mountain range. So continental oceanic is when one continental plate and one oceanic plate collide, and the oceanic plate will always subduct underneath the other continental plate. One telltale sign of a oceanic or continental oceanic plate boundary is a trench, which is a valley in the water. And then the last one, oceanic, is when two oceanic plates collide. And another telltale sign of this is a trench, seen right here. Rules to remember with convergent plate boundaries is that the denser or heavier plate will always subduct beneath the less dense plate. And convergent plate boundaries are considered destructive plate boundaries because they converge and one plate always goes underneath and gets destroyed by the mantle. So a subduction zone, which is something that we saw in the last slide, is a site where one plate edge descends into the mantle and is remade into new magma and later new plates. And then an island arc is a series of volcanic islands created through oceanic plate boundaries. An example of this is the Hawaiian Islands. If you look closely on a map of the Hawaiian Islands, you can see that it is a constant stream or string of islands that was created by a volcano in the ocean. And you can see that the largest island is the main island of Hawaii, and the other islands get smaller and smaller because those islands are slowly eroding into the ocean. A volcanic arc is a belt of volcanoes formed by the oceanic continental plate boundaries. An example of this is the Yellowstone supervolcano, and it is actually a string of multiple other volcanoes, just the rest of those volcanoes are dormant at this point. A trench is a long, narrow valley on the seafloor that forms from oceanic plate boundaries. An example of this is the Mariana Trench, and partial melting is what is responsible for the creation of volcanoes and island arcs and volcanic arcs and all that stuff. It is a selective melting of solid rock based on mineral melting temperatures. Different minerals have different melting temperatures based on their composition. So the second type of plate boundary is divergent plate boundaries. Divergent plate boundaries, there are two different types of them. One is continental divergent plate boundary, and that is where two continental plates move away from each other. And this is shown in this little illustration here. It creates a rift valley as the two continental crusts move away from each other. And then that later, you can also see the spreading of the crust, and that means that the magma is closer, and it either fills in with water or volcanoes and all that kind of stuff. And then the second type is oceanic divergent boundary. That is when two oceanic plates are moving away from each other, and that two oceanic plates moving away from each other causes a mid-ocean ridge because magma is floating up to being pushed up to the Earth's surface and causes the ridge. It's like a little mini mountain range kind of, and the ridge is always a little higher than the rest of the plate because those plates, or that material that is newly formed, is less dense and therefore taller. As it gets older, the material starts to condense and get thin and dense. In contrast to convergent plate boundaries, divergent plate boundaries are considered constructive plate boundaries because they create more material as the two plates are moving apart from each other. And another important rule to remember with divergent plate boundaries is that new material is less dense and becomes more dense as it cools and ages. That is also partly what is responsible for allowing certain plates to move underneath each other. A rift valley is a lowland depression formed by the splitting of tectonics or faults. An example of this is the Red Sea over near Africa, or in the United States, the Rio Grande River. An oceanic ridge is an underwater mountain range formed by oceanic divergent plate boundaries. An example of this is the Mid-Atlantic Ridge. Seafloor spreading is when new oceanic crust is formed by rifting in the seafloor. And rifting just means movement away, like they split apart. And partial melting is also a case in divergent plate boundaries, just like it is in convergent plate boundaries. The last type of plate boundary is transform plate boundaries, and this is most commonly the hardest one to understand, so you guys might take a while to understand it, and that is fine. Let's do some definitions first. A fault is a planar or angled fracture in the rocks of Earth's crust caused by compressional or tensional forces on either side of the fracture. So compressional just means like together, bringing together, getting closer together. Tensional is a force that is applied by an object being stretched. So that means that the plates on either side of the fault are being stretched from somewhere. A footwall, if you look at the model or picture down on the right-hand corner, the footwall, you can see that it is hanging, it has a lip that is underneath this other part of the fault. So it is the underlying rock of the fault. The hanging wall, it hangs over, hence the name, the overlying rock in the fault. And transform plate boundaries are what cause earthquakes and tsunamis, which an earthquake is a vibration of the ground caused by the moving plates of Earth. Energy stored in Earth's crust is released suddenly. Three types of transform plate boundaries. The first one is probably the most common one, is a strike-slip fault. Rocks on either side of the slip fault slip horizontally past each other. An example of this is the San Andreas Fault in California. A normal fault is the next type of plate boundary, and it is decompression forces. So they are getting drug apart from each other, causing the hanging wall, the one that hangs over, to slip down over the footwall, commonly found at divergent plate boundaries. An example of this is the East African Rift. And then a reverse fault is compressional forces, so they are being smashed together, are causing the hanging wall, the one that hangs over, to slip up the footwall, commonly found at convergent plate boundaries. An example of this is the Rocky Mountains. So let's do a little bit of review over what we learned today. What does this picture show from the type of boundaries that we learned about? I'll give you a couple seconds. This type of boundary is an oceanic convergent boundary, and this is shown by the two oceanic plates, this one here and this one here, that are colliding. And the partial melting that is shown by these little arrows right here creates a volcanic island arc in front of the subducting plate. So the subducting plate is this one here, and the partial melting or the volcanic island arcs will always be found in front of the subducting plate, because as the subducting plate moves into the mantle, when it reaches a certain place in the mantle, like down here, it gets heated up enough and it causes the magma to rise and burst into a volcanic arc. So what type of boundary does this picture show? I'll give you a couple seconds to look over it. This is a oceanic continental convergent boundary. You can see that by the oceanic crust is subducting into underneath the continental crust. Like I said earlier in the slideshow, the oceanic crust will always subduct into the continental crust because it is denser because of the basalt. And another telltale sign of the convergent boundary is this trench right here, that valley that you see. And then partial melting, that's shown right here, causes a continental island arc, or continental volcanic arc, pardon me. And a mountain range is also created from the compressional forces of this plate smashing into the continental plate and smashing mountains together. What type of boundary does this picture show? So this is a strike-slip fault. It's a type of transform boundary. And you can see this by the two plates are slipping past each other. You can also see this by the telltale sign that it is a horizontal movement. One plate is not moving down or up. You can see the vertical fault line right here. This is the last one of these. I'll give you a couple seconds to think about it. Is a divergent oceanic plate. This one might be a little hard because you might get confused by this ridge right here. But earlier in the slideshow I said that new crust is always less dense and therefore thicker. It rises a little bit more. So you can see that by the two oceanic plates are moving away from each other and the mantle is creating new seafloor. So this example here, it's a little bit of a tricky one. Give you a couple seconds to look at it. So this example is actually an example of multiple different types of boundaries, all of which we talked about today. So I'm going to go through this right to left, and I'm going to start over here. You can see that the first one is a continental divergent boundary or a rift zone. You can see that the plates or the continental plate is getting a little bit of a dip in the crust, and you can see that it is also thinning. The magma in Earth is getting a little closer to the surface because the crust is slowly spreading apart. The next one is this one right here, and it is a oceanic continental convergent boundary. You can see that by the oceanic crust that is subducting underneath the continental crust. You can also see that by the trench, and the trench is the point of subduction for these two plates. The partial melting is shown right here by the subducting plate reaching a deep enough point underground and getting rose up and creating rising up and creating a volcanic arc. You can also see here that the continental crust is getting a little bit crumpled and compressed by the little deviation in the ground, and that also causes the mountain range to be created. The next one is a oceanic divergent zone, or a seafloor spreading ridge. You can see that by the two oceanic plates right here, this one and this one, going apart from each other. And you can also see that in the ridge, and you can see that the ridge is ever so slightly taller than the rest of the surrounding plate. And that is because newer material that is created by magma is less dense and therefore lighter, and it takes up more space. The next one is a little bit harder to see, so if you didn't get this one, that is okay. And it is shown by this discontinuation between the oceanic spreading ridge here and here. And this is an example of a strike-slip transform boundary, which you can see that because there's this gap. The two plates, or the plate, is getting pushed or pulled in different directions, causing the oceanic spreading ridge to slowly get pulled apart from each other. The next one is an oceanic convergent plate. You can see here this oceanic plate is getting subducted underneath this oceanic plate, which means that this oceanic plate must be the older and denser plate compared to this one, because always the older and denser plates will get subducted underneath the older and newer plates. You can also see the partial melting here, causing a stratovolcano and a island arc. This one also shows a trench that you can see. And as you can see by this example, is that all of these types of boundaries work together. They are what is responsible for Pangea moving apart, because if the oceanic spreading ridge right here, it creates more oceans and causes continents to spread apart. These right here, the convergent zones over here, they cause continents to be moved together and new or old crust to be destroyed by it subducting into the mantle and being recreated as new crust. This one right here is an example of new seas or oceans also being formed because the crust is spreading, and then either magma or water will fit that in. So this is a good example of what was happening to India during the spreading or the breaking apart of Pangea. When it left the main continent of Pangea, it was getting pushed by an oceanic ridge right here. And then when it was smashing into what we would call Russia and India today, it was like a continental convergence zone. And that's why the Himalayas were created. So I hope this helps you guys understand the different plate boundaries. I have this video linked online to further review the things that we talked about today. If you have any questions, this might be able to answer that. So after you have watched that video, then you can have the rest of your class time to do your homework. It is not a long assignment, so you should be able to get it done within the class period, but it is due tomorrow, so if you don't get it done in class time, remember to do it at home. If you don't understand something, you can always feel free to email me, and also discuss amongst your classmates. It's a great way to learn from each other is to discuss. So have fun on your homework and have a good day.